Hello Squiz, this is Squeeva here with another YouTube video, and in this video I'm going to be doing some organic chemistry. Now I did say I wouldn't be doing much more organic chemistry, but I changed my mind, I will. Yeah. So anyway, let's get right into it. The first thing we're going to be doing in this tutorial is resonance structures and nomenclature. This is kind of, I'm doing these tutorials in very random orders. I really don't have much particular reasoning as to why I'm doing my tutorials like this, but I am. So, let's get started with resonance. Now, the first thing we need to know is what is resonance. Resonance is the redistribution of atoms. And, yeah, it's just really the redistribution of atoms. Wait, electrons. It's 7. My brain is shut off. I've been doing schoolwork all day. Not really, I've been sleeping, but shh, I'm doing schoolwork all day, quote unquote. Anyways, let's get right into it. So the first thing we need to know is how are we going to distribute electrons throughout this entire molecule? Well, why do we want to distribute electrons? Well, because this is unstable because this positive charge right here. Oh, crud, that's the worst. Because of this positive charge right there. That is making everything unstable. So how exactly can we fix this? Well, the first thing we know is that we have 2 hydrogens coming off of here. Or, I forgot to draw this in earlier. We have 2 electrons there. So we know we have 2 electrons there, and we want to make this. I forgot to draw that in, but I realized if there's 2 hydrogens here and there's hydrogens everywhere, it's kind of impossible to perform any resonance. Because there are rules to resonance. The first rule, you can't have more than an octet. So 2, 4, 6, 8. Right? So this bromine has 1. This is 2, 4, 6. And then that other double bond will be an 8th. Be an 8. So we won't break an octet there unless we know we have a hydrogen here. So we'd have to move that hydrogen around, but I wouldn't worry too much about that right now. I do warn you, it's been a little while since I've done any orgo. I recently did my benzene bob, and if you've seen them on my blog, I cannot wait to get to reactions if you couldn't tell. You probably can't because no one can read my mind, mainly because it's just all over the place all the time. But the next thing is reactions, and that I know well. That I've pretty much... Reactions and structure determination I've done a lot. You know, resonance and orgo, you spend maybe a day or 2 on it. There's a quiz, there's like 2 lessons, some practice, and a quiz. With reactions, I think we spent a total of like 2 months on reactions. It was quite a lot of reactions. So, resonance is a bit harder for me to remember, but what I can pick up is we have 2 electrons here. What we're going to do is we're going to draw a resonance arrow, which literally just looks like an arrow. That's a resonance arrow, so we're going to draw it there. And to denote resonance, you're going to draw kind of like that type of arrow, and then we can just draw in our cyclohexane, our cyclohexane, and we can draw in, it's no longer stereo center, so I'm not going to draw that in, but we have that, and we have that, and a minus charge here. So we have that, and then we have a bromine up here. We have a bromine. Now what we need to do is we still have that positive charge there because we put more electrons here. So what we need to do is we need to draw yet another. Unbelievable. Unfreaking believable. You have to draw another resonance arrow, breaking that double bond and going here. That's another resonance rule. The big resonance rules are you cannot have more than an octet and you cannot break a double bond. Okay? That's like the key thing, is not breaking double bonds. Or, I'm sorry, single bonds. You can always break a double bond. Single bonds. You never break single bonds. Because that's pretty much saying these electrons just leave. They just hit the road and they're gone. So that's kind of impossible, if you know what I mean. Okay, so we do that, and then this is going to turn into... Wait. A cyclohexane, a double bond here, and a double bond there, and of course we have our bromine. very poorly drawn in. So that's our first resonance structure. Now we can move on to this resonance structure, which is very easy. You just move that over there, and there you go, you've completed this resonance structure. That's easy as heck. I don't even need to draw in the steps. It's just that, which will turn into, which it will basically turn into hat, with, of course, this. Of course, it'll turn into that, so this will turn into that, and then we can go ahead and do the other resonance structures. So here, we have a plus charge here. Literally, all we're going to do is this. There you go. You've done it. That is now solid. So these are a lot of one-step resonance structure problems. I'm not going to give you any practice problems here. I will lead you to practice problems websites in the description, but I'm not going to give you any practice problems. Okay, here we can see it's the same molecule, except with instead of a cyclohexane, we have a benzene. Benzene is a bit trickier. And the first thing we got to know, positive charge, they want more electrons, because that means they have an electron deficiency. Negative charge, they want to get rid of electrons. So this guy's going to go here. Okay? This is going to jump on over to here, this carbon, because you can't have, at any time, you cannot have more than octet. This is going to jump here, and then this is going to jump right there. So then this is going to jump there. This is going to jump there. And then this is going to stay there. So what you're going to end up with is going to be, you know, that. You got a benzene. So really what it does is it redraws the double bonds. And it's no longer really a benzene, because now we have this double bond here. So then we're going to have these two electrons here, because remember, you can't have more than an octet, so this isn't going to go there, this is going to, really, this is delocalized now. Delocalized means it can't move anywhere. So then there's localized and delocalized. Of course, localized means the electrons can move. So here, if the electrons are here, they can move here. But if the electrons are here, they can't move there, because then you'll have more than an octet, and, you know, you can't move this anywhere, because it's a single bond. You can't move that anywhere, it's a single bond. Really, you're stuck there. So that is resonance. That is very basic resonance structures. I feel like all of this is correct, although I got a decent grade, not a great grade on my orgo exam, but, you know, this is pretty much resonance structures. Now let's move on to some nomenclature. So there's actually a lot of nomenclature. We'll be visiting a lot of nomenclature as we go along. I'm going to lead you to a list of all the nomenclature suffix or suffixes that you can have. So there's a lot of prefixes and a lot of suffixes. So the first thing we want to know is, how does nomenclature work? Well, nomenclature works by having, you start off with, you want to find the longest chain. That's the first thing you want to find. So going from here to here wouldn't be the longest chain, but going from here back around to here would be the longest chain, if you know what I mean. So the first thing you want to do is find the longest chain. We know that the longest chain is the cyclohexane here. So remember it 1. Now, so we can number it 1, 2, 3, 4, 5, 6. Now, because this is chiral, I believe this is pretty much chiral. Wait, no. No, it's achiral. This is achiral. So, what that means is it doesn't really matter which way you go exactly. I mean, usually it doesn't. Actually, more often than not, it really, really doesn't matter. Unless, I mean, it gets more specific. Sometimes it does matter. I don't know. It's confusing, you know? In our case, it doesn't matter. In some cases, it does. You know, like, if you want to label something on food stuffs, you know, you do that. Anyway, and this comes in very handy. If you ever are reading labels and you see something that's like 1-methyl-4-nitro-toluene or some, that's TNT. Anyway, like 4-nitro benzoic acid, you know, you can draw the different stuffs. The different molecules. Come on, OBS, get out of here. Get out of here. Okay, so, enough farting brain. So we've numbered it. Now we could go this way or we could go this way. In our case, it doesn't matter. So, let's get naming. So the first thing you want to know is, well, nomenclature works by having each dot, each carbon has a number. So we know that's going to be one methyl. So one methyl. So one methyl means it's on the one spot there's a methyl group. Two, okay, now what is intuitive is to go 2 nitro, 4 nitro, 6 nitro, because, you know, but no, it's 2, 4, 6. So it's be 2, 4, 6 nitro, okay, cyclohexane. There we go, we have our nomenclature. So this is this molecule. So 1 methyl 2, 4, 6 nitro hexane, cyclohexane. So we know it's a cyclohexane because it's a ring, and we know it's hexane because it has 6 carbons. We know there's 1 methyl because we have a methyl on our 1 spot, and then we know that it's going to be 2, 4, and 6. So on the 2, 4, and 6, there are going to be nitros. And as you can see, if we labeled it the other way, 2, 4, and 6, it'd be the same thing. So it's 2, 4, 6 nitro. Alright, I hope you understood that. I go a bit fast. Okay, so here we have another carbon chain. One thing to keep in mind, I believe it's going to cut off here, because here you have a functional group. So here's our ketone. So I believe it's just going to split right there, and it's going to be 1, 2, 3, 4. It's going to be butane. I might be wrong. I would check to see if you include the ketone on your straight carbon chain, but I don't think you will. So let's get started with numbering. So we're going to start, so the first thing you want to know is where's the highest priority. Is it going to start here where there's no methyl, or is it going to start here where there is methyl? Well, it's going to start right here. 1, 2, and then 3, and then 4. It's all about a priority, because here you see, I didn't bring up the priority because there's no real priority, but like here, it's a carbon attached to no carbons. So that's less than a priority if it's a carbon attached to a carbon. It's just, the priority is just something you have to have a sense for. You have to just, your priority, organic priority senses have to tingle. Your organic chemist senses have to tingle, if you know what I mean. And you're not going to include the 4 because 1, 2, 3 is less than 1, 2, 3, 4. And it's not going to be 1, 2, 3, 4, 5, 6, because then you'll have a 4 and a 5 on the same carbon. That's just one thing to keep in mind. So what we know we're going to have, now I'm going to include all the suffixes in the description, and we'll link a website. So what we're going to have is we're going to have 2 methyl butanon. Butanon is the ketone. So that's what we have. These here are our 2 nomenclatures. That is nomenclature. That is resonance. I feel happy. You should too, because you learn something every day. Now, what I would like to see in the comments is if you include the ketone or not. I'd actually enjoy knowing it. I'm gonna look it up, but I just want to see if you guys figure it out. I'll probably put it in the description. But I don't know. Anyways, that's all for this tutorial, squids. Thank you all for watching. Please like, subscribe, comment, check out the channels of the other squids. Yeah, all that good stuff. And do the practice problems I gave in the description. Alright, squids, thanks for watching, and adios.